go ahead and ask me. I have written down the output also on the side. So are there any questions on the quiz? Okay, so I guess none of you have any questions on the quiz. So I'm going to just continue with the aggregate functions today. So this is the last lecture on SQL. Just bring this up. Um, so so for now, at least, it's the last lecture. I'm going to finish with aggregate functions, and I want to move on to design. And then at the end, I'll come back to SQL because there are some features that I haven't really covered, which I would, if I get time, I wouldn't mind doing it because SQL also has advanced features like recursion and stuff like that, um, um, and analytical processing and stuff. So I might just come back to it. So we were looking at this particular query, list the last name of employee who earns the maximum salary. And I gave two options in the last class, and none of which works. I mean, you can also try doing it. You could do it. Let's try. Let's look at this next one. So, sorry, it's not working. Okay. Select last name, max salary from employee. So let's say group by SSN having max salary. So, so you could try something like this. This is also not going to work. So I gave 3 wrong solutions. So let's look at the correct solution for doing this problem. So this is, again, you're going to do it like a nested query. So this would be select last name, salary from M, where salary, and then you use a nested loop. So you can say select max salary from M. So where salary, you can say where salary N, select max salary from M. So this is the correct way of doing this particular query. I'm trying to, and because the output of select max salary from emp is a single value, you could have also written as, instead of using in, you could have also written is equal to, where salary equal to select max salary from emp. And that's because the nested query only has one output. So let's look at the next query. So list the department number of employee who earns minimum salary. So in the previous one, you wanted to list the last name. Here, you just want to list the department number. So it's really exactly like the previous one. So it would be select DNO from emp, where salary equal to. So like I said, you could, since it's a single value, you could use an equal to instead of an n, and then select min salary from M. Okay, so I'm going to now, going to modify this particular query a little bit. So I just want to show you how to do, the aggregate functions. They're extremely useful, and you can do some rather complex queries with them, but you have to be a bit careful. I mean, sometimes it looks more simple than it really is, the query. So sometimes you kind of do it without putting that much thought into it because it seems so simple, but you can make mistakes that way. So let's look at this next query. Okay, now select the last name of employee. So last time I was doing the department number. So now I'm saying I'm going to modify the above query. So now select the last name of employees that are in the department. So let's say above one. Okay. Okay, so now we want to list all the employees that work in department, um, um, that where you earn the minimum salary. So you want to select the last name of employees that are in the department. So let me just pull up the company SQL. Where is it gone? Yeah. Okay. So we have so the department where employee earns the minimum salary is going to be, I think 25,000 is a minimum salary out here. So we're going to have, okay, so we have department, actually it's only one department. I thought department number, oh, there's also department number 5 where they earn 25,000. So you have two departments where they earn the minimum salary. Okay, so now we want to select the, the last name of employees that are in the department where salary is equal to minimum. So we want to list out the employees who work in both department number 4 and department number 5. So we do this query. So again, it's a nested query. And then you put the above query in, select D number from employee. Where salary equal to. Okay, so you just have to do an additional level of listing out here. And the only thing you have to pay here is, here I could write an equal because min salary will only return one value. But here, if you wrote an equal, it would be a mistake because D number, there are two departments where people are earning the minimum salary. So so this was another one with query. So now let's look at this next query. So we have, So this is, I'm going to have a few queries that kind of follow through. So query number 1 is for each department, retrieve the department number and the count of the number. So, and the number of employees who earn greater than 40,000. So we did a query similar to this in the previous class. So if you look in the department table, there are only, there's no one in department 5 that earns more than 40,000 because in department 5, 40,000 is the greatest salary. So it's really department 4 and department 5. So the output we are looking for in this particular case is D number and the count. And so we should have department number 4, and then count of the number of employees who earn more than 40,000 is just 1. And the same thing with department 5, the count is just 1. So this is the output you're going to get for this particular query. Okay, so so this query, again, we have done earlier, something similar to this. So this is a relatively easy query. We can just say select DNO, count, okay, so we've done something similar. We did, I think, the same thing or something similar in the previous class, but I'm going to build on this query. So I'm going to do the next query, which is a follow up on this one. So query number 2 is, so now for each department that has more than 1 employee, so let's write down. So for each department with greater than 1 employee, retrieve D number and the number of employees who earn greater than 40,000. Okay, so now just what I'm asking is slightly different from the previous query. So I'm saying for each department with greater than 1 employee, retrieve D number and the number of employees who earn more than 40,000. So if you look in, oh, just a minute, I did this one. This should be 1, by the way. I made a mistake here. It's department number 1. Okay, so now when I look out here on the left, if you look, department number 1 only has 1 employee. So the output I'm looking out here, I just want the first row out here. I just want D number, count, and all I want is department number 4, and I want count of 1. I do not want department number 1 to appear in the output. Okay, so so the question is, how do you do this particular query? So remember in the last class, I had also given the having things. So if I wrote down, for example, so let's go back. So if I update this query and I added one more line, if I said having count star greater than 1, do you think this would work? Do you think that this would give me the right answer for this particular query, for query 2?
No, because it's already applied the where clause.
Yes, if I did write count is greater than 1, I would get an empty set. Because if you look at the out here, it's already done the count, so and the count is 1. So I'm not going to be able to do this by just saying having count greater than 1. So this is what I was meaning, that that some of the aggregate functions you would have to think a little bit about. They're not as simple as they look. So I'm going to write down the answer for this one. So we have so again, all of these, most of these, you have to use nested queries. So let's look at the answer for this one. So we say select. Okay, so I'm just going to try to close the, okay, I'm trying to, I guess I'll have to write that out here. So select, just one second. Okay, select e dot d number. So this is a nested query, count star from employee E, where E dot salary is greater than 40,000. So, and then I'm going to have the nested query. So, and exists select star from employee E1, where E dot D number is equal to E1 dot D number group by E1 dot D number having count star greater than 1. Okay, but and this last thing, you have to also group the outer one. So you have to say group by E dot D number. So this is the answer for the query number 2. So just take a look at it and see if you understand what this is doing. And while you're taking a look at it, I'll write the same subquery using the in. So I could have written this down as and E dot D number in so you could have use the in instead of the exists. It's the same thing. So I hope if you haven't understood why this works, just let me know. And again, I really recommend that you try this out, and especially just see how, if you did not write a group by E dot D number at the end, what would happen. So yeah, so try it out, because it's not going to give you a mistake, but it won't give you the correct answer. So now let's look at this next query. So for every department with more than one employee, so So with greater than one employee earning less than 30,000, list the number of employees. So for every department with more than one employee earning less than 30,000, list the number of employees. So first, before you write down the query, can you look at the sample database and tell me, just try to figure out what the output. So what is the output for this particular query? And then we can write down the query itself. But first you have to look and see if you understand what the output is, if you can figure out the output. So what is the output for this particular query? What would be the output that I'm expecting? So anyone, can you just can volunteer? Can anyone volunteer and tell me what would be the output for this? What are the department number that will be listed? And will it have 2 rows or 1 row, this output for the sample database?
Just one, I think.
Okay, that's right, because with more than one employee, if you look at on the left side, we have only one employee in department 5 who earns less than 30,000. So that's in Joyce English, while department number 4 has 2 employees. So for every department with greater than one employee earning less than 30,000. So there are 2 employees in department 4. So only department 4. But so the next one is, what would the count be? Will the count be 2, or would the count be 3 for this one? What is, I mean, because I want to make sure you understood the query that I'm written down in English. So from interpreting what I wrote down in English, I mean, am I looking for a 2 or a 3 out here?
3, right?
Yes, so that's so I just want to make sure you understood. So my whole point of this was that what I'm asking is that for every, exactly, so department 4 has 2 employees that earn less than 30,000. While department 5 only has 1 employee earning less than 30,000. So I don't list department 5, I only list department 4. But what I want is the count of the total number of employees, not the number of employees who are earning less than 30,000, but the total number of employees in that particular department. So there are 3 employees in the department. So this is the query I want to do. So I'm going to write down the query in SQL, and I want you to see if you understand the query. So again, like that's what I said. I mean, this query is not, I mean, it's not straightforward. I mean, it would require some thinking to do it. So I'm not asking you to do it. You can just look at what I'm doing, the solution. So the subquery is select E1.d number from employee E1. So now here is where you're going to write the conditions. So where you want is where E1.salary is less than 30,000, group by E1.d number. And now here you have to write the count. So having count greater than 1. So that's a nested query. And then, of course, don't forget, you have to group the outer query, group by E.d number. Okay, so if you have any questions, you can ask. I just want to make sure you understood this. Okay, so this was it. I mean, on the next assignment, the SQL assignment, which will be the last of the SQL assignments, I'll give a few queries where you use the aggregate functions. So once you, I mean, the best way to learn some of this stuff is to try it out on your own on the sample database and then just do a few queries. I mean, they're not really hard or anything. It's just that it's good to practice. So now I just want to, I just want to write down a few random stuff here and there in SQL that's useful to know. There's no real topic right now that I want to do. Like I mentioned, now I'll come back to SQL maybe at the end of the semester. But right now, I just want to do some stuff that's given in the book that I haven't really gone over. So one of them is the all operator. So let's look at this next query. So we have select last name, first name, with salary greater than. Okay, so I mean, this is a simple query. You are selecting the employees from department number 5 who earn the maximum salary, or sorry, we are selecting all those employees who earn more than the maximum salary of the employee in department number 5. So I think employee in department number 5, the max salary was, I think, 40,000. So there were 2 people who earned more than 40,000 outside it. So you can do the same query using the all function. So that would be so where salary greater than, and then you can say all. Okay, so if you do not use the all function, you would get an error because select salary from emp where d number is equal to 5. It doesn't give you one answer. There are all the salaries from department number 5. So what you want to pick up are employees who earn greater than all the salaries. So instead of using the max, you could use all. So just wanted you to know about that. Then there are other functions that are good for other aggregate functions that work on the entire database. So one of those is the rollup function. So we have Okay, so select D number, sum salary, average salary from employee, group by DNO. Now, if the end you use this, you say with roll up. So the output is going to be so you have DNO, sum, average, and then the sum from department number 1 was, okay, I'm just going to write down 55,000. The average was okay. And then when you say with roll up, it gives you another line with aggregates. So you're going to have one more line that is going to say it'll be null out here. And then you'll have 28100035125. So what it does is that it will do the sum of all the, so out here, it'll do the sum of these 3 rows, and out here it'll do the average of all these rows. So if you use a roll up, you get, one additional row that does the kind of summary. And instead of putting null out there, if you wanted to change the value, you could have written this down as, so if you wrote down as select, and then you say if, let me write that in a different, if I said select if null, and then D number, summary, has department, and then you have some salary, average salary from employee, group by DNO, with roll up. So if you, instead of writing null, if you wanted something else out there, then you can do that. So what's going to happen is that instead of null, it'll say summary. And then it writes down. And then sort of DNO, it's going to be department. So you can have, it's just a good feature to have, the roll up. And it's actually kind of powerful too. So, but right now I just want to just show you what you can do with that. You can also do, aggregates as a column. So for the next one, let's do. So if I wrote select D number, SSN, and then I wrote sum salary. Yeah, so let me write that in a different. Oh. Sum salary over as grand total. And then I wrote down some salary over, and now here I say partition by DNO as department total. from employee. So this one, again, is one of these functions that will sum over all the rows in the database. So the output for this is going to be okay, and then you have okay, and similarly we do for the last one, that's department number 5. So you're going to have 5. And then you have their sum total for them. Okay, so that's how, so you can even do for columns. Yeah, it's just, I just wanted you to just know that there are these aggregate functions that work over not just, we can work over the entire database. So I'm trying to see. And then I guess the last thing that I do want to mention, which I think I find it useful for writing queries. So this one, so I'm done with this part, the aggregate function. So let's look at this next query. Okay, so select dname dlocation from department left join department location, and then you say on, and it's department dot d number is equal to department location dot d number. So it's a bit of a pain whenever you use left join. When you do the natural join, you don't have to do, you don't have to write the D number again. But when you're doing left or outer joins, you always have to give the field on which you are joining. And it's a bit of a pain having to keep writing that down. So you could have written down this query in the following manner. You could have written it as select from department left join department location. And then you could have written it down. So you can say using D number. So I just wanted you to know that there are other, alternate ways of doing it. So, so does anyone have any questions? Because this is pretty much it on SQL that I want to do for now. So I'm would like to start up on design after this. So I want to leave SQL aside for a while, and I'll come back to it because we have to get back to things like constraints. So we're going to do design for a while, normalizations and ER diagrams and stuff like that. And then after that, I'll come back to SQL where I'm going to talk about constraints and recursion and stuff like that. I don't know whether I'll get to recursion actually, because there are constraints and concurrency, about how you do the asset properties. So I'll have to come back to SQL at that point. But for now, this is it on SQL. So does anyone have any questions?
If we could go back to query number 2 there, I still don't I don't get why the having count greater than 1 didn't work.
Or you're talking about this one?
Yeah, that returns the empty set there.
Yeah. So look, so this query is actually working on this one. So select the number count from employee where salary is greater than 40,000, group by D number. So when you do a count, the count is coming as 1. So for this particular
Oh, okay, I see. Okay, that's why it's empty. Okay, I'm like, why isn't that not work?
Yeah,
Okay.
yeah. So that's because of the so that's not what the query really asked for anyway. So you have to do that is why you have to, you'll have to do it in a different manner. So that's what I meant, that aggregate functions are deceptively simple. So sometimes in a query like that, you would, you know, think that this would be the solution for it. But that's not it. So what I meant is that, so this time we're not going to have a midterm exam or anything like that. So all I'll be testing aggregate functions is on a quiz. But, on a midterm, if you were actually typing in a query and doing it, you'll make a mistake the first time around, for example, and then you'll figure out my query, you look at the sample database and say, you know what, my answer is not correct. What am I doing wrong? And then eventually you'll figure out that the way of doing it is this way of doing it. But on an exam or a quiz, these, it's very easy to make a mistake because you would think, oh, you know what, this will give me the right answer. So that's what I kind of meant, is that for SQL, it's very easy to come up with questions with aggregate functions which are tricky, and it's easy to make mistakes on them. So anyway, your class is lucky. You're not going to have a midterm. So you don't have to deal with it at all. It's going to happen on a quiz. So that's all. Yeah. And on
All right, thank you.
yeah, I'm going to be using the airport anyway. So it's a simpler one. Yeah. So I'm just saying that, normally this is a very, it's easy to come up with questions with aggregate functions that are, that look deceptively simple, but are not. So I would definitely recommend that you try out, especially, try some of the ones that I did in the last class. They were all very easy. So I would like you to try these ones out and just play around with them a little bit. I think your textbook also has queries on group by and aggregate that, so you can just try them out. So anything else? Do you have any questions? So if you don't